Hello and welcome to another lesson on radioactivity. Today's lesson is on nuclear equations. First, we're going to recap some stuff from last lesson. So if you pause the video, you can write some stuff down and check yourself on the next slide. Check your answers, and if you got it right, give it a tick. If you got it wrong, you can add in the correct answer now. Today's lesson is on nuclear equations. We are going to do a quick recap of the atom, look at atomic and mass number, and then we're going to look at some nuclear equations followed by some practice. Have a look on the left-hand side. We have a lithium atom. Now the lithium atom, you can see in the middle there, has got 3 protons and 4 neutrons. So the red ones are protons and the green ones are neutrons. So this number here, this number down here, this is called the atomic number. And this is the number of protons in the atom. This is the proton number. And the proton number is really important because it defines the atom. If you have 3 protons, then that is lithium. It doesn't matter if you've got 100 million neutrons or 1,000 electrons. If you have 3 protons, that is a lithium atom. The top number is your mass number. And your mass number is the number of protons and neutrons. So that's everything in the nucleus. So your bottom number is just protons, and the top number is protons and neutrons. So therefore, we can easily work out how many neutrons are in the atom. Because if we know that there are 7 things in the nucleus, and 3 of them are protons, then it's easy to work out that we have 4 neutrons. So just to recap at the bottom, first of all, 3 protons, because it says the number 3 on the atomic number. Straight away, we know that there are also 3 electrons. Now this number is always the same for an atom because atoms are neutral. They have no charge. And protons are +1, so this would be a total charge of +3. Electrons are -3 because they're negative, and neutrons are 0. And this would total 0 charge. So you must have the same number of protons as electrons in an atom. And the last number, 4 neutrons, we did that by doing 7 minus 3, because we have 7 things in the nucleus, 3 of them are protons, so that must be 4 neutrons remaining. Pause the video and have a go at the one on the right. So how many protons, neutrons, and electrons are on the right? We can straight away see that there are 26 protons because the atomic number is 26. So 26 protons, and straight away we know 26 electrons. Now we know there are 56 things in that nucleus, 56. 26 of them were protons. So therefore, if I do 56 things minus the 26 protons, there must be 30 neutrons, and that's how I got this number down here. Pause the video now and have a go at these 3. So I want to know how many protons, neutrons, and electrons in each atom. This first one is 20 protons. The atomic number is 20, so it's 20 protons, 20 electrons, always the same, so the charge is 0 because we've got plus 20 and minus 20. And then we do 70 up here. This is protons plus neutrons up here. We know 20 of them are protons, so there must be 50 neutrons left. Second one is 11 protons and 11 electrons, because the atomic number is 11. Now we know there are 23 things in that nucleus. 11 of them our protons. So we do 23 minus the 11 protons. That gives us 12 neutrons. And the last one, we've got 3 protons, 3 electrons, and we do 7 minus 3 to get 4 neutrons. I've made some atoms up so you can have a practice. So pause the video now and have a go at these 6, and then I'll put the answers up. So the answers are up on the board now. You can check your answers for the number of protons, neutrons, and electrons. On the screen now is a table. What you can do is copy the table and have a look at your periodic tables. Choose any from the first 20, any element from the first 20, and then you can write down the atomic and mass number from the periodic table. And then you can calculate the number of protons, neutrons, and electrons from it. If you pause the video now, I'll next give you a clue for the first few. That will help you, and then I'll give you the answers for the first 20. So there's a clue below. I've done the first 3 for you. We've got the atomic number and the mass number written down, and then I've calculated the number of protons, neutrons, and electrons. You can choose this for any element in the next from, I don't know, 4 to 20, and I'll put the answers up on the next slide. The answers for the first 20 are now on the screen. You can pause the video and compare your answers to the answers on the screen. Okay, pens down while we look at the next section. Pause the video briefly and try and remember what these 3 are made of. We looked at them in a previous video. So alpha was made up of 2 protons and 2 neutrons. It is a helium nucleus. Now the symbol for alpha looks like this. And we can see in that diagram there are 2 protons. So therefore our atomic number at the bottom would be 2 because there are 2 protons there. And there are 4 things in the nucleus, so we can write down 4. And this is the same for every alpha particle. Whenever there's an alpha particle, we can just write down 4, 2, alpha. It's the same every time. Beta is just a high-speed electron. So this is made up of a high-speed electron. And the symbol can either be a capital B with a tail or an E for electron. Now, beta doesn't have anything in the nucleus, so this number is 0. And the bottom number is actually -1. So this is 0 minus 1. Either is okay to use the B or the beta or the E. Now we'll come on to why there is a -1 later in the video. But you just need to remember for now, alpha is 4,2 and beta is 0 minus 1. The last one is a high energy wave. A high energy wave. So it looks a bit like, oh, that's awful. So it's a high energy wave. The symbol for gamma looks like this, and that has 0 things in the nucleus, 0 protons, so that number is 0, 0. So those 3 on the right, alpha, beta, gamma, you need to memorize those 3. And we'll use them in the next slide. Here's an example of an atom decaying. If we look on the left-hand side, we've got a lithium atom, and we can see in the nucleus there are 7 things in the nucleus. We've got 3 protons and we've got 4 neutrons. Now on the right-hand side, you can see it after it decays. So we used to have 7 things in the nucleus, and you can see that this alpha particle has been spat out of the nucleus. Now the technical word for that is emit. It's been emitted. The alpha particle has been emitted. Emitted alpha particle. And we say this is decayed. It has decayed. Now we can see from the remaining diagram what's left. We can see that this is what's left. We've got 3 things in the nucleus, so that's why this is a 3, and one of those is a proton, so that's a 1. And the alpha particle is 4 and 2, so that's always 4 and 2. Now you might ask the question, how did I know this was hydrogen? Well, remember that the proton number defined the element. And we've only got 1 proton left, so that must be hydrogen. You can look that up on the periodic table and find that is hydrogen. So now we know that that lithium decayed into a hydrogen plus an alpha particle. And we can turn this into an equation by doing this. So we can say lithium decayed into a hydrogen atom and I suppose it's a hydrogen isotope and an alpha particle. Now there's a really good way of checking yourself here. You can see that we started with 7 things in the nucleus and we must end with 7 things in total. So we have 3 and 4, which adds up to 7. We started with 3 protons in the nucleus and afterwards we have 1 and 2, which add up to 3. So that's a good way of checking ourselves to see that we've done it correctly. If they don't add up on each side of the arrow, then we've made a mistake and we can go check. I'm going to have a go at the top equation to show you how it's done. And then you can pause the video and have a go at the second 2. So the one at the top, I can see there was 86 protons. 86 protons. Now once it decays, I know that alpha is 4,2. It's always 4,2. It takes 2 protons and 2 neutrons with it. So that means there used to be 86. 2 have left, so there must be 84 left. And the top number, 219, it has lost 4 things from the nucleus, so this is now 215. And we can double check ourselves because we started with 219 and 215 plus 4 is 219. And we started with 86 protons and 84 plus 2 is 86, so we are correct. So pause the video now and have a go at the next 2. We can see that this uranium atom started with 92 protons. And we know that it decayed into thorium plus this alpha particle, which is 4,2. It's always 4,2. And if I started with 92 protons and 2 have left, there must be 90 left. If I started with 238 things in the nucleus, 4 of them left, so there must be 234 remaining. Now we can double check ourselves by saying we started with 92 protons and we've ended up with 90 plus 2. And we started with 238 things in the nucleus and we've ended with 234 plus 4, which is 238. So that's correct. Last one is this made up equation here. We started with 60 protons and we know that alpha's 4,2. So therefore 2 have left from the original 60, so there's 58 left. And out of the 100, we lost 4, so there are 96 remaining. And we can double check ourselves. I started with 100, so 96 plus 4 is 100. And I started with 60, and 58 plus 2 is 100, so we know we're correct. Next, we're going to have a look at beta decay. Now, this is quite a weird one because something really unusual happens. But once you understand that bit, then you can kind of work out the rest of it. On the left-hand diagram is your lithium atom, and on the right-hand side, you can see what's happened by looking at the nucleus. We started off in the nucleus with 3 protons and 4 neutrons. And on the right-hand side, we've actually got 4 protons and 3 neutrons. You can see that this neutron in the bottom right here has actually turned into a proton. And this happens. So the first thing that happens is a neutron literally turns into a proton. Now that's really strange, and that's why it's quite hard to understand, but it does. That neutron turns into a proton. But it can't do that for free. You've made some positive charge. And you can't just make positive. You can't start with neutral and then end up with positive. So it also makes, you create an electron as well. So we start with a neutron, which is neutral, and we end up with a proton and an electron, which is also neutral together. They're neutral. Now, what's really important is to realize that electron is coming from the nucleus. It doesn't come from the shells around the outside, which is where the other electrons are. It's coming from the nucleus. And the reason why it's coming from there is because it's coming from that neutron that turned into a proton. And that is beta decay. It's a high-speed electron being emitted from the nucleus. The equation looks like this. Now we can see we started off with 3 protons in the nucleus, and we now have 4 protons in the nucleus. You can go and count them, 4 protons. But there are 7 things in the nucleus and then 7 afterwards, so that number's not changed. Now you can see why the numbers on the beta particle are 0, because it started with 7 and ended with 7, so that must be a 0. And we started with 3, we gained a proton, so that must be -1, because these two together must add up to 3, because we started with 3. And that's why this is -1. You might be wondering how I knew this was beryllium. And the answer is the proton number. Because it has 4 protons, we can look in the periodic table and see that that is beryllium. So to turn this into an equation, all we need to do is do this. So that lithium atom will turn into beryllium 74 plus a beta particle. And we can use either an E for beta or a B with a tail. The final check is we can add up the numbers before and after. There was 7 mass number before, and there was 7 plus 0 after, and there was 3 before, and then 4 plus -1 is also 3, so that's correct. I'm going to have a go at question 1, the one at the top, and then you can pause the video and have a go at 2 and 3. Now, I started over here on the left with 86,219. And we know that beta always has the numbers 0, -1. Every beta does. It doesn't matter if I use the beta symbol or the E. And also I know that this 86 protons turns into 87 protons because one of those neutrons turned into a proton. There's still 219 things in the nucleus because that neutron turned into a proton, nothing left. And to double check, I'm going to check the number before was 219, and these two together make 219. And before was 86, and these two together add up to make 86. So that is correct. Pause the video and have a go at question 2 and question 3. Question 2, we can automatically put in 0 minus 1 because every beta particle is 0 minus 1. Then I can see uranium started with 92 protons, and one of those neutrons turned into a proton, so I'm going to gain a proton here. And in the nucleus there was 238, and that stays the same because nothing's left the nucleus. There's proton number, and the number of protons and neutrons is the same. And I can double check by saying 238 before it decayed, and these two added together make 238. And we started with 92 before, and these two together add up to make 92. So that is my second equation done. And the last one, this is some made up elements, I think. Yeah, it is. We can automatically do 0 minus 1. We started with 50 protons. One of the neutrons turned into a proton, so we've gained one here. And the number of protons and neutrons stayed the same. And to double check, these two add up to 80, and these two add up to 50. And we know that because we started with 80 and 50. Good, so that's the third equation done. So if you want to pause the video and have another go at that, you're welcome to. The last one we're going to look at is gamma decay. Now, gamma is a high energy wave. So this one has 0 protons and 0 things in the nucleus. So we could draw the equation looking like this. So it has 0 protons and 0 things in the nucleus. So if I started with 7, I'm going to end with 7. And if I started with 3, I'm going to end with 3 because both of these numbers are 0, 0. Now, because this number is 3 on the left and this is 3 on the right, the element doesn't change. If I have 3 protons on the left, I'll end up with 3 protons on the right. So it's still lithium. So it doesn't change the element because the proton number is the same, but it does lose energy. And it does that by emitting a gamma wave. Lastly, we're going to practice some nuclear equations with gamma. So the first thing is we know that gamma is 0, 0. And it's lost no protons, so that's still 86. It's lost nothing out the nucleus, so that's still 219. So this element here must be, it still stayed the same. Because it's got 86 protons before, 86 after, so the element has not changed. The second one we can do by knowing this is 0, 0. We know the mass number's not changed, the atomic number's not changed, so it stays as uranium. And the last one is 0, 0. The atomic number's not changed and the mass number's not changed, so this stays as element L. I think that's a made up one. And this is how to do nuclear equations that emit gamma radiation. So if you want to pause the video, you can go back and have another look and have a go at that one. That's the end of our lesson on nuclear equations. If you got stuck at any point, you can pause the video or go back and re-watch that section.